This is the inverter display screen. The inverter display screen is going to give us real-time information specific to the inverter. The first light here is the AC input. This AC input is our grid connection. When the AC light is on and solid, that means we have a solid grid connection from our existing panel. If the light turns off or starts flashing, that means that we have a lost AC power from the grid. Next light here is the generator AC2 input. That is for an external generator to be able to charge the batteries in the event of a power loss. This particular system does not have an external generator connection. Our event log, so if there is an event, power outage, or a problem with the inverter, or problem with the charge controller, the event light will flash and the display screen will have an event error. You'll be able to look up in the operations manual for the inverter and we'll tell you what the error is. If not, contact your system installation company. The equalization light, the Conext system will automatically equalize as needed throughout time, or you can press this button to force an equalization. Next set of lights here, this is our battery status light. This shows the status and the amount of available energy estimated into the battery bank. So our system currently is full when all 5 lights are on. That means the battery bank is filled, and as energy is used off of the battery bank during an outage, that the number of lights will turn off and go down, and you'll be able to see that the battery is losing power. At some point the inverter has a low voltage disconnect. If the battery voltage gets below, I think, 40 volts even, the inverter will shut off to protect itself and to protect the loads. In grid-tied selling during the day while you have excess energy, this will display the amount of kilowatts, that's the amount of watts at 1,000 watts of energy that is being converted excess off of the batteries and selling into our existing load panel. The light, when it is selling, the kW light will be flashing, and the numbers you're seeing is the actual amount of kilowatts. So currently we're running about 2,000 watts of exported energy. That energy is first going into the house. If the extra energy is still available than the house needs, it'll go out to the grid. During a power outage or the AC1 power goes out, the system will then convert the energy from the batteries and power our critical load, and the kW light will be solid, and the amount of energy that you're powering your critical load panel will show here in kW. Remember, this inverter is a 5,000 watt inverter, so the max kW we can either sell or that we can convert during a power outage is 5,000 watts. After you've had a power outage and the AC input light comes back on, the AC can charge the batteries. This is an inverter charger, and it can charge the batteries from the AC input. During that time, you'll see the amperage light on and the amount of amperage that's going in to charge the batteries. This bottom right button is the AC power button. This is the power button to turn the inverter on and off. Here we have the charge controller that's converting the solar energy from the 600 volts from the roof and converting it to 48 volts of DC. And when the green light here is flashing, that means that we are charging, and that means it's working. The event light should be off normally, but if there's an event or a fault or a problem, we'll have a red light here. And during equalization mode, that is where the system is topping off of the batteries and kind of managing and maintaining the batteries, you'll have the equalization light on. The system will do that automatically. There's nothing you need to worry about or to worry and to do. Here is the display screen. On the display screen, the top line says select device. We're on the select device screen, and the items you see here are the different devices. We have 4 buttons to be able to scroll up or down. You press the down or up arrow and you'll see that the cursor, the highlighted area, moves up and down. To select an item, put the cursor on that item and then press enter. If you want to move backwards and you want to move up in the menu, you press the exit button and that'll take you back to the select device screen. On this screen here, we have system settings. That gives us an overview of the settings real time, what's happening right now. The next item here is the XW inverter. Default will have XW 5048, and I changed it to say XW inverter for user function. So if we click enter, that'll give us the information specific to the inverter. Here is the XW charger. This would give us information on the MPPT 600 volt charge controller. And here is the display, so if we click on that, that'll give us specific information to the display screen. Next we have the clock function. This is where you set the time of day and information. So as you can see here, current time is 5:15 p.m. Our date is May 27, 2016. We have 24-hour time, and we have set the time zone is Greenwich Mean Time minus 5 hours. To make a change, you highlight here. We'll make the change from 12-hour to 24-hour military time. You press the enter button and the highlight comes over here to the right, and then you can see your selections. We can choose 12-hour time or 24-hour time. Press enter, and then you can see up here our set time went to military time, so it's 17:16. So set that back and press enter to go back to the main screen. From the select device screen, we're going to press exit and we'll go back to the system status. The system status screen is the system information of the total package and the total system. The first line here tells us the battery. Shows us here at the top right that our battery bank voltage currently is 55.6 volts. It is a 48 volt battery bank, nominal voltage, but the batteries are basically at 98%, 95% fully charged, and our battery voltage is high. Plus the system is set to cell, so the battery voltage, everything above a specific voltage will be taken right off the top and will cell into the grid. Currently we have 4.6 amps of energy that's going into the batteries. This is a brand new system, and in a brand new system for the first 180 minutes or 3 hours, it will automatically go ahead and charge the batteries at a absorption rate to charge them at a full percentage. So currently we have a little bit of energy going in. Normally we'll see maybe some energy a couple times every hour, keep a trickle charge. The next line here is the load line. Load line currently shows that's our critical load panel, that our critical load panel currently is drawing about 995 watts. The AC input connection, that's our input connection to the inverter, to the system, is running at 120 volts. And the negative wattage means that we're actually selling and exporting energy out to the grid. That's why you have a negative. So the system currently is powering our critical load panel. Excess energy is going out through our AC input 1 connection and out to the grid. Next we have our time and date here. If we click the down button, that goes and gives us the status information for, you can see the top line, XW inverter. It shows the status of the inverter as set to cell to grid. That means we're selling excess energy. Showing you that they're pulling some energy in and out of the batteries, and the battery voltage, our load again, and that's the information real time on the inverter. We can scroll down and give us information on the XW charge controller. It shows that it's an absorption rate to give those batteries a top off charge. And then we're back to our system status screen. We're going to press enter, and that'll take us over to our select device screen. A common question that I receive quite a bit is, how much is the solar producing and what is the solar doing currently? So from the system status screen, you're going to press enter. That'll take us to the select device screen. We're going to scroll down to the charge controller. Remember, the charge controller is our converter from PV energy into battery energy. We're going to press a XW charger. Then we can come down to meters. That's going to give us the real-time information of what the system is producing. Currently, the PV input power is 1,900 watts, and that PV input is correlated at about 8 amps at 248 volts. So the solar panels are putting out 250 volts at about 8 amps. Once the charge controller takes that and converts it down to 48 volt system, our AC output power is roughly about 1900 watts. There's a little bit of a loss in that conversion from higher voltage to lower voltage. The amperage output is at 38 amps at 56 volts. That charge controller is constantly monitoring the battery voltage and making the output voltage equal to what the batteries need. The reason that the amperage on the output, at this case, is 40 amps and the input is at 8 amps is because of the voltage difference. The PV input voltage is much higher, so the amperage is lower. As the voltage is lowered from 250 volts down to 50 volts, now the voltage is lower but the amperage is higher. Volts times amps equals our watts. Next, we can go back and we can see the harvest logs. This is going to give us the logs over time. We can highlight harvest logs, click enter, and we can see how much energy the system made today, this month, and then this year. Let's look at the daily logs, and you can see that today on May 27th, we've produced 8 amp hours at 0.4 kilowatt hours. Kilowatt hours is 1,000 watts over time. I just started this system up and the system just turned on a little bit ago, so our number is fairly low, but that means we've produced 500 watt hours or 0.5 kilowatt hours. That's watts over time. Our peak power for today has been 2,500 watts, and our float time is just kind of starting up, and that basically means that the energy is being sold and excess energy is going back into the grid. Now that we're done viewing this information, we can click exit. We can see the monthly log, the yearly logs. We can press exit again, and we can go back to our select device or to our system status screen.